Hello everyone. Today I will be talking about how washing your hands with soap can actually kill and prevent the spread of COVID-19 and why it is the most important thing to do right now. So please, instead of hoarding toilet paper, go wash your hands. So first, I'll start off with the basic overview on why using hand sanitizer or water is not as effective as actually washing your hands with soap. While using hand sanitizer is a good backup, it is ineffective in removing the harmful germs on your hands, and in many cases, like if your hands are really dirty or greasy, it doesn't work. The reason why hand sanitizers are unable to actually remove the germs, or in this case viruses, is because it only breaks down the protective membrane of the virus, which makes them fall apart, so it's still on your hand. Therefore, if you do not have access to soap and water, it is still recommended to use hand sanitizer with every chance you get. But why is it that scientists and doctors recommend you to wash your hands with soap and not just water? It is because soap has certain chemical properties that water is missing. So let's dive in deeper into the chemistry behind soap. Soap is a mixture of fat or oil, water, and a basic salt. When combined, the ingredients undergo a chemical process called saponification, which results in soap. The structure of soap is really peculiar. Unlike a water molecule that is polar, which is basically when electrons are unequally distributed in a chemical bond, soap molecules have a nonpolar and polar part to it. The soap molecule has two main parts, a tail consisting of a long hydrocarbon chain and an anion or negatively charged ion head. The tail's long hydrophobic chain has nonpolar and hydrophobic or water-fearing properties. The anion head has hydrophilic or water-loving and polar properties. The nonpolar hydrophobic head attaches to the nonpolar dirt, grease, or oil, where all the germs are, and the hydrophilic polar end attracts the polar water molecules through ion-dipole interactions, which are intermolecular forces that involve an ion and a polar molecule. So let's first talk about the chemistry behind soap and water. When we mix soap with water, the salt molecule, or in this case, we will use a sodium atom represented as Na, separates from the soap molecule, leaving one of the electrons from that sodium atom with the oxygen atom in water. This results in a negatively charged water molecule and a positively charged sodium ion, because the sodium ion lost one of its electrons while the water molecule gained that electron. Referring to what was said previously, this attraction between soap and water is an ion-dipole interaction. But now if we explain it in a more specific context, the sodium ion becomes attached to the water molecule, which mentioned before is a polar molecule. Therefore, it is an ion-dipole interaction. Then, as the soap dissolves, hydrogen bonds, another type of dipole-dipole interaction or a polar molecule interaction, form between water molecules due to the attraction between the slightly positively charged hydrogen atom in the water molecules and the negatively charged oxygen in the water molecule. Now that we have a somewhat good understanding of the chemistry aspect of soap and water, let's tie that knowledge into the current event of the pandemic and how exactly the interaction of soap and water can actually kill and remove viruses. First off, it is important to explain some characteristics of viruses. Viruses are able to stick to oils and grease and accumulate on our hands. Referring back to the question on why just water is ineffective in removing and killing the viruses or other germs is because water and oil don't like each other, and since viruses stick to oils, water won't be able to do anything. But soap, like said before, likes both water and oil, so soap binds to the both of them at the same time. When the soap attaches a molecule of grease, dirt, or oil to a water molecule through weak London dispersion forces, which are intermolecular forces that exist in all molecules, a micelle forms. A micelle, which is a ball-like structure formed from nonpolar tails of the molecules that clump in the center, is formed for every molecule of dirt. A negatively charged oxygen ion of the micelle soap molecules attaches to the positively charged hydrogen atoms of water molecules through hydrogen bonds. This results in reduced surface tension, and the micelle containing the dirt, which is now attached to the water molecule, is able to go down the drain. So in simpler forms, the soap attaches dirt to water, which forms a micelle, and that micelle is able to bond with water molecules through hydrogen bonds, so the water drags the micelles with it down the drain. Unlike hand sanitizers, which only disturb viruses, soap removes them completely. That is why it is important to wash your hands, especially during a time like this. Because the virus is contracted from contaminated objects or surfaces, the best way to prevent and protect yourself against COVID-19 is to wash your hands for at least 20 seconds to capture the germs. Thank you for watching. For more information, please check out all the websites I used in this video for further explanation. It will be linked in the description box. If you have any questions, please leave them down below in the comments section and I will try my best to answer them. Stay safe and wash your hands. Bye.